Hello, this is the Tepid Coder. In this video I want to talk about abstract classes. Personally, I'm not a fan of abstract classes. I think they're a bad idea. I prefer function composition. There are multiple reasons why I don't like abstract classes. One of them is the fact that they're slower than just using composition. Another is that they're really hard to reason about, I think. I mean, other people might feel differently about that, but for me that's the case. So, another thing is about them, you kind of have to dynamically allocate memory in order to use them. I'm going to kind of show an example here. So, what I kind of want to do for this, what I always want to do when I'm trying to make these tutorial videos, is to think about what a practical application of some language feature would be, so it'll maybe sink in better. Be like, oh, that's what it's for. That's why it's used. That's how you do that. I don't want it to be like, oh, here's something you can do. Like, you can make, an array, right? Say array for integer array of 10 integers. Cool. I can assign it to, 1, 2, 3, 4, whatever. But what does that do for me? Why do I want 10 integers? What's the point of having integers, So, what I'm going to do here is I'm going to think of an example that will actually use abstract classes in a way you might see it in a real project. So, sometimes maybe you're selling software that does something for a user. You provide some service. And maybe there's tiers for that service. So, what I'm thinking here is perhaps we release a service that encrypts files for people. And maybe depending on whether they have the free service or they have a paid service, they're going to have better types of encryption or just more options for encryption, that kind of thing. But in this case, I'm just going to say they have different types of encryption that are increasingly strong, right? So let's say we have class encryption. Okay. Inside here, let's make our constructor encryption. And then we have the structure for encryption. Now, for a abstract class, we need to mark things as being virtual. The destructor should definitely be virtual. The reason for that is the wrong destructor will be called when you free the object. It'll free the object by calling the destructor for the base class, which is the first one. There's going to be other classes that include the components of this class and extend it, or at least just change the way it behaves. And that one might actually have memory that's dynamically allocated. Like this one right here, private, there's basically nothing to see here, right? But the class that derives from it might have some kind of memory that it's managing. And if you don't mark this as virtual, it's going to call the destructor for this base class instead. And it's not going to free those resources. It's going to cause memory leak. So, what I'm going to do here is I'm going to say you have a function called, void, encrypt. Okay, that's our function. It's going to take password to encrypt it with. It's going to take, I'm going to say uint pointer UI8 array. Okay. In fact, let's be more C++y about this. I've already showed you guys vectors. I'm going to use that. So let's just do this. A vector of unsigned 8-bit integers. I'm going to pass it by reference. Okay, and this is not going to manipulate the class at all. Any variables defined in here are not going to be changed. Okay, this is going to be a virtual method. It's not defined here. I'm not going to say what it does. I'm going to say equals 0, which is saying it's completely virtual. If anything is marked as 0, it means that you actually can't create an instance of this class. You can't instantiate it. So int main void 0. If I try to say encryption, right, E, it's not going to let me do that, even if I, define the default constructor here. So encryption, right, and it's equals 0 here. Okay. So this doesn't exist. It's virtual, and this is virtual, and it's pure virtual because I'm saying it equals 0. If it doesn't equal 0, then you can actually maybe create the class if there's none that are pure virtual, if is equals 0 here. And you can always still just create a function in the next class that's going to overwrite what this one does. But I'm making these pure virtual. So I just want to show you that since there's pure virtual functions that equal 0, it's not going to let me instantiate a class object here. So I'm actually going to do this, g++ test test. Cannot declare variable e to be abstract type encryption, because the following virtual functions are pure with encryption. So within the encryption class, there's virtual encryption. Right here, this equals 0, and virtual encryption encrypt is also equals 0. See that? That's why. Okay. So what you can do now is make a new class that derives from it. So I'm going to call it XOR encryption. And you say public, which means everything from this class becomes public in this one, unless it's marked as private. If it's marked as protected, then that means can be viewed by classes which derive from this one. Now this class, when you put a colon here, it means it derives from this class. It's going to take the properties of this class, like all the variables that I define, and all the functions I define, or methods I should say. Okay, so let those be public to this class, called XOR encryption. I'm going to say public to this class is the constructor, XOR encryption. Let's go and paste that. Having trouble typing encryption today. And then we're going to need to actually create this, right? So it's going to be virtual. This is also virtual. And it's an override. Overriding the function. Okay, virtual encrypt standard vector, unit reference, call it v, const star, password equals not equals 0. In this case, we're actually going to define it, and this is going to be an override. We're overriding the function. Okay. Now, I'm going to actually say XOR encryption. We're going to do the constructor, XOR encryption. Okay. Really nothing to see here. There's the destructor. Just so you know the right one's being called, I'm going to say printf XOR encryption destructor called, right? Okay. What else can I say here? Right, XOR encryption, encrypt, not encryption, just encrypt. And we're going to say it takes a standard vector, unit call it v for vector, char, WSC, password. Okay, so now what I want to do here is I'm going to say, in fact, this needs a type here, void. Did I do that over here? I did, yeah, good. That's good. Did I make it const like I should have? No, it should be const. Yeah. Okay, over here it should be const. You can't put override right here, but you get to put const. Okay, and we know what? No except, because this shouldn't ever really be throwing any exceptions. Okay. It's a bit crazy with all these qualifiers. Anyway, I'm gonna say st length equals string of password, and because of that, I need to include string.h to get that string length function. So I'm gonna say for sti equals less, so it's less than st length. Go to the next character. Okay, and then what I'm going to say is v position, oops, sti equals, actually XOR equals, LPSC password position sti modulo st length. So I'm going to XOR it by the value of the current character in the password, and once the password has been, length has been exceeded, it's going to go back to 0. And what I really want is not this length right here. What I want is, sorry, b.size. And I'll try to pull that out and say size t size. I don't know. Vector size, vector length equals b.size, right? I should call this password length be more descriptive. Okay. Vector length and elements, right? So this is going to keep growing to the length of the vector that I'm encrypting, which is probably going to be a lot longer than the password. And because of that, I want to make sure that the character in the password that I'm using is only between 0 and the length of the password minus 1. So now, let's pretend that the length of the password is 10 bytes. So we have, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9 bytes. A would be 10, right? So the positions you can use are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So the length being 10 here, you can use that minus 1. 0 to that minus 1. In general, it's just 0 to length minus 1 is the index range. So what I'm saying here is modulo the length. Well, imagine I'm dividing something by 10. The remainder can only be numbers 0 through 9, right? So like 11 divided by 10, right? It's going to be 1, remainder 1. Now if it's 12, it'd be remainder 2. 13 divided by 10, it'd be remainder 3. I'm going to skip up to 19, remainder 9. But if I go up to 20, right, the remainder is going to be 0. And that's going to be true if I go to 29, the remainder is going to be 9. But if I go to 30, it's going to be 0. So by making the modulo equal to the length, I can only have things between 0 and the length. So that's why I'm doing this. So it's going to keep starting with the password. Let's say the password is test. It'll be, T, then it'll be E, then S, then T. And then it would be accessing something out of bounds, so it goes back to this T again, then E again, then S again, then T again, then T again. It's just going to keep doing that over and over again because of the modulo operator. Okay, and this is mutable, that's right. So let's shoot XOR the buffer. So here's what I'm going to do. I'm going to say standard vector unit 8t d. We're going to say v dot what insert. I'm going to say v dot again. I'm going to insert into it, let's say UI8 array values. Okay, and the values I'm going to give it are going to be t. That's going to be like, I don't know, 4. I'm going to say it equals tst, right? Okay. Cool. So now if I say, let's see here, has to be a pointer, it's going to be equals, I'm going to say XOR encryption. So this looks a little bit funny because what I'm saying here, and actually I can't do that, I say new. What I'm saying here is this class type equals a new instance of some other class type. So that's something you can do here for encryption. You can have a base class, which is virtual, be assigned to an object of a different type that derives from it. So because this is virtual, it's not actually defined. You can't instantiate it. It's like more like an interface. You're saying how something's going to work. And this is like, I forgot to actually say, it's deriving from encryption. This is saying, here's how I'm implementing encryption. Like, this is the interface, here's how I want it to work, and here's the implementation, here's how it actually does work. So, anyway, the size of this could be less than the size of this. So I can't just say, it somehow equals this. It has to equal a new pointer to it. And I think I mentioned this already, but the size of a pointer is going to be consistent if it's a class pointer. Just in case I didn't mention it before, a pointer, like an int pointer, is always going to be, like, if we're in x64, it's 8 bytes, right? And if we're in x86, it's going to be 4 bytes. With a class pointer, though, like encryption, or XOR encryption, or whatever, these are going to be bigger, because they not only need to say where the class is in memory, but it also needs to say, like, what type of class it is. Is it XOR encryption, or maybe I have another one called AES encryption, something else like that. Anyway, so that's what I'm doing here. I'm saying that there is basically some kind of encryption mechanism, and it just happens to be XOR encryption. So now I can say e dot encrypt, encryption encrypt. I'm going to say v, and I'm going to encrypt it with the password, I don't know, ABA, which is actually going to just be B, because the A and the A are going to cancel each other out with XOR. So I'm going to do ABC. Why not? Okay, then we're going to say, how about for, I'll use some modern C++, const auto v for value, Yeah, I can't do that because we have vector here is also called v. Not val from vector. I don't usually like using short variable names for this reason. I'm just gonna say set it out. Okay, value u8 unsigned d-bit integer, and we're gonna say val. Okay, and then this right here needs to be freed, so we're going to say delete e. Now this is interesting. Remember, we marked the destructor as being pure virtual, so you can't really delete it. It doesn't know how to call a destructor. But because we have this kind of class, part of the pointer information it is storing is what kind of class it's actually using. It's not just like, here's where the class object is. This is also the type of the class object. This is type right here. So it knows to use this destructor. So the destructor for this class is over here. It's going to say extra encryption destructor called. And maybe it would free some memory or something if it had to. So delete, in this case, is going to know how, because of the information that's stored in the class. Okay, so let's just try that real quick. C++ test.cp test. It's going to let me... Ooh, that's a lot of stuff here. I think that is cleared in the scope, so nano, plus 45, test.cp. Okay, right, I called it password length. Okay, I'm actually going to just preemptively use this to compile. Okay, so what do we have? No matching function call for standard vector insert begin. Oh, right, I never finished doing that because I was explaining something. Okay, so what I really want to do is I'm going to say start at this value. One of the constructors, not constructors, one of the things you can do is you can insert based on a range into a vector. So I'm going to insert based on the start value. So this, remember, is the same thing as, it's going to be uint 8t bracket bracket like that, which just becomes this. So it's also the same as saying that, right? The first element. So it's the first element up to the size, right? So I could say size of UI8 array values, right? So that's the same thing. I don't really need to put this here though. And if I wanted to, I could even just say that. That's the same thing. Now keep in mind that this range it's inserting, this is the starting point, right? The starting element. This is like the sentinel element. So this would be the first element after the range that we want. So if this is S and this is E, then the range is actually going to be S to E, not inclusive. So everything from here up to but not including this. That's what's happening here. Okay. So. Okay, 57. Not declared the scope. Okay, let's see what that is. Right, values, not value. Okay. And didn't like that. Reference to encryption. Right, that's not what it's called. Okay. Where is that? Encryption. Good. X1 encryption, X1 encryption. Encrypt. Right. Virtual void. Const no exception. This is an override, right? Yep. Okay. Encrypt here. Let's maybe space this out a little bit so I can see better. Make sure these are the same definitions. Both const no except. Both virtual void. Both taking uint8t for the vector. Mutable vector, non-mutable password. Const no except, this is overwriting it. XOR encryption, encrypt, so it should be, right? XOR encryption, encrypt. So virtual you wouldn't really need here. Override you wouldn't need over here, but it is const no except. And it is taking standard vector, uint8t's, immutable reference to password. Let me take a look at this again. So it's looking for encryption. Why would it ever try to reference that destructor? It's pure virtual. That shouldn't be happening because I've said it's pure virtual. Right? So encryption here. Yeah, virtual encryption, destructor 0. Does it? It should understand that what I have here is actually this. Maybe I can't have a pure virtual destructor for some reason. I might have been confused about that. Encryption. Okay, and let's say it's not pure virtual then. Well, it is virtual, but not pure virtual in this case. Let's just see what happens then. Yeah, okay, I guess you can't have a pure virtual destructor. But either way, the proper destructor is called with 2 Ds. That's embarrassing. Oh my. Alright. There we go. And just for fun, let's look at the base destructor. Encryption called. So does that actually get called? Shouldn't. It does. So I guess you have to... No, it doesn't. Does it? Yeah, it does. Yeah. Jeez. Brain's not working great today. Anyway, I guess you have to free both the base class and this. I'm a little bit confused by that, but okay. Anyway, something I want to do here is I'm going to abstract this away into a function. I'm going to say void print vector, right? In fact, let's look at the template. Why not type name t? I'm going to say standard vector of t. Specify copy its const, and I need to do type name that. Okay, and then I'm going to paste that. It's already const. Now I don't want to do that because I won't know the format specifier token to use. I mean, I could use like a v format thing. I'm not going to do that. Let's just keep this simple. I'm just going to do that because I'm expecting that and I don't want to change everything. This is already simple enough. So print vector, I'm just going to say v. Okay. I want to print it before I encrypt it and after I encrypt it, so I can see the values changing. I'm going to say pilot. Okay, so we have these 4 values, then we have these 4 values. And let's see if the values are the same once we're done re-encrypting it. Alright. So, oops. And 84, 84, 101, 101, 115, 115, 116, 116. So it did work, and here's it encrypted. Right here. Normal, and it's going to be encrypted to here, and then unencrypted again. Okay, so that's one method of encryption down. And what I could do now is I can make a new class quickly. And I'm just going to say something like class Caesar encryption. Something like that, okay? This would be like a shift kind of encryption. So public, I don't need any private anything. I'm going to do Caesar encryption constructor. I'm going to do the destructor, which is virtual, and it's an override. I'm going to make that same virtual void encryption, but it's actually encrypt. And it's going to be override const, no, except override, yeah, okay. It takes a standard vector of type uint reference, and it takes a immutable string, which is a password. Right, okay. I'm just going to copy this whole thing, so that's a data type. Don't need the virtual here. Don't need the override here. Okay. I do need to see the class though. The old Caesar encrypt. Yeah, okay. Cool. Okay, think here for a second. What I want to do, I think, is just shift everything by the value of the byte of the password. So I'm going to say for I'm going to keep this simple, size t. You know what? I can keep it even simpler than that too. You know what? AT equals. Okay, I'm going to start the pointer to the first value in the vector, and then what I'm going to do is I'm going to have pointer to the final value size. Actually, it's the first value after, so that's my sentinel node, right? So I'm going to say while LPY 8p is less than LPY 8e. So until I reach the sentinel node, which is the first character after the end of the vector, 8p is plus. I'm going to go to the next character time. And then while I'm on a character, I'm going to say p, in this case, plus equals, I'm going to say OPSC password and say index. Okay, I'm going to say st index plus, I'm going to say index modulo st password length. Okay, and then over here I'm going to say size t length equals the length of the password OPSC password. Okay, and I need to define t index. So I'm going to start at index 0 of the password, and I'm going to loop through 0 up to the length minus 1 over and over again, just like before. So whatever the current index is, it's going to be that up to the length of the password, and then reset to 0, and then go up to the length of the password. And I'm just going to keep incrementing it this way. Okay. I'm going to do one more thing here. I'm going to say bool crypt equals false. So, yeah. Right. So I'm going to say, just to make this quick, char, I want to do it this way. Yeah, I do. I'm going to say c sign equals decrypt question mark -1, otherwise 1. So what I'm going to add is c sign times this. So if I say to encrypt, which is basically I don't want to decrypt, then let's see, it's false by default. If it were true, we're going to multiply -1, so we're going to add a negative number. But if we're not decrypting, then we're encrypting, so we're going to have a positive sign, 1. So 1 times anything is itself, so we're going to add. So if we're encrypting, add the value. If we're decrypting, then subtract the value. So every single item here is just going to increase by some shift. So if you have like the letter T, let's say you have letter S, and you add 1, it's going to be a T, right? And if we do the opposite of that, the T becomes an S, because we're subtracting 1. That's what's happening here. Anyway, let's try that real quick. Let's make a new thing here. We'll call it encryption e2 equals new Caesar encryption. Okay. Right, and we're going to delete e2 when we're done with it. I want to say e2 encrypt. Encryption is encrypt. And we're going to do the vector again. We're going to say we see the password. And I want to do print vector b. Right. Let's print this over. Wow. That's going to be really annoying to fix. Okay. Ah, dear. Okay. What I wanted to do was print it before I mess with it, then encrypt it, and print it again, and then decrypt it, and we'll print it one final time. Okay. Right. Alright. Let's deal with the errors I created. So, marked override, but does not override. This is on line 73. 73. So, is that true? Does it not override? So, Caesar encryption, did I actually define this anywhere? I don't think that I did. I didn't define the constructor either. So, let's do that. Okay. Okay. Let's let everyone know that we are calling this. That called. Okay. What else do we screw up? Okay. Override, but does not override. I disagree. We're definitely overriding that. Okay, so let's use encryption. What does the base class say? So, encryption, virtual encryption. Yeah. Structure encryption override. That's what I'm doing there. Okay. Yeah. So why is it not happy with that? That should definitely be overriding. Marked override, but does not override. How does that not override? Because for XOR encryption, I'm doing the exact same thing. Virtual. It's called XOR encryption. It's an override. Right here, XOR encryption. Am I doing something weird back where I define it? No? Spell something? No? I'm actually a bit perplexed right now. Okay. This is looking correct to me. What else is it complaining about? So const, no accept, override. Right? There's got to be something else weird going on here. You know what? I think I know what happened. I think I forgot to... I did. Yep. I forgot to actually derive from the class, public encryption. So it's right that it's not overriding because I didn't actually say it comes from this class. It's deriving from encryption. This is another reason I don't like using abstract classes, just because the error messages are so cryptic on them. They're very unhelpful. No declaration matches this. Okay. So it's void. It takes a vector reference. Const character pointer. Right, I never actually defined it as taking a bool argument in this one. So let's fix that. I don't know if I can put the decrypt equals false in both places. I don't think it's going to let me. It does not override. Yeah, in this case... I have to think about that. Here's what I'm going to do. I'm actually going to make this a little bit easier. I'm actually going to say decrypt. I'll give it an encrypt and a decrypt for each of these classes. Do it here too. I'll call this one decrypt. Over here. Okay. Decrypt. Okay. Now, what I'm going to do for this is be a bit lazy, because I can. Think smarter, not harder. I'm just going to return. I don't return anything actually. It's just going to be decrypt, but I'm going to call encrypt because XOR encrypting and decrypting are the same operation. I'm going to say v obviously password, right? So that's the same thing. Now for this, I kind of hate to do this, so I'm duplicating logic, but I think I'm just going to make a separate function just to be lazy. I mean, I could call it a common function. Maybe I'll do that. I think that's exactly what I'm going to do. I'm just going to say shift. you know. Basing on whether I'm decrypting or encrypting, it's going to be shifting forward or backwards. I mean, I could say like backwards, shift left or something. That's basically what this is. If decrypting, then shift left, you know, subtract. So that's what I'm going to do. I have this function right here. This one isn't going to be virtual. Right, okay. And I can't have this in here because I'm inside the class definition or declaration. Okay. And then for each of these, I need to define what's happening. So this one's going to do the meat of the work, right? But then I'm going to make 2 more of these. So this one is going to be my encrypt. This one is going to be my decrypt. Okay. And they're both just going to call the other one. So it's going to be shift v, LPSE password. I'm going to do false, right? And actually it has a default argument, so I could just do nothing, but I'm going to put a false here. Make it explicit. Okay, I'm going to do shift. I'm going to say the password and true or decrypting. Okay, and then what else do I want to do? I'm actually going to get rid of this like default value. I'll just keep it as simple as possible. No reason to make things complicated. I'm going to say over here now, just to be consistent, decrypt, even though encryption and decryption is the same thing in XOR, I'm just going to say it. Okay, encrypt, decrypt. There we go. A little happier with that, because now everything's consistent. So 68, no declaration matches void decryption, or encryption decrypt. Void extra encryption decrypt. Really? 68, okay. Candidate is virtual void extra encryption decrypt. Const. Did I not put const at the end or something? Let's check. 68. Yeah. Const. And no accept. Okay. Right. Yep, const no accept. Cool. Accept const, yep, Shift, const no accept. These, const no accept. Const no accept. I think we're probably good there. Okay. There we go. So we have TEST, which is 84.101, 115.116. Then we have these 4. Then we have the same values again, 84.101, 115, 116. Cool. So this works. And what I might have now, finally, I don't know how many minutes later since I started this, but we have something where if we have like different customers, like I was saying, we might give them different types of encryption depending on like their service tier. So let's finally do that. We'll say something like, trying to think here, customer, right? We'll say something like private, and we'll say encryption, E, there has to be a pointer to it. It's going to start with null pointer. We'll say public, we'll say customer, okay. In fact, I don't want to do that again. Okay, and then encrypt, right? We'll do the same thing, standard vector, UNT reference, and it's going to be const char password, const, and this is going to be void. In fact, I don't even need to do that because it's built into here, but I mean, I'll do it anyway. I'm going to say customer, so our constructor, okay, destructor, right, and then we're going to say customer encrypt, okay, vector 78 t char password const, and it's going to return void. Okay, so what I'm going to do here, I'm just going to say me in this case. Maybe ENC for encryption, slightly better, still bad. Encrypt. Just going to pass it through OPSC password. We're going to say decrypt. Do the same thing with the password. Okay. Decrypt. Okay, so it's going to use whatever encryption method we specify. I'm actually not going to have a default constructor. So delete and say customer, and we're going to give it encryption, right? We want to pass some kind of encryption method to it. All right. So this is deleted. So this one right here is going to have encryption pointer. We're going to say me equal, or menc equals nc. So now void test whatever, was not that in there for now. What I could have is customer new XOR encryption, right? Customer, we'll say new Caesar encryption. Okay, and then inside of the destructor here, we're going to need to actually free customer destructor called. We're going to say delete NC. Because we can't have a default constructor, we know that this has to actually be assigned to something. Alright, so yeah. So we'll delete it at the end. Okay. Something else I can do as well is I can just say something like standard vector t, just v. I'm going to say I have char sc string, like something to be encrypted, right? Equals, you know, this is a secret. And I'm going to say something like v dot insert. I'm going to say v dot again. So insert right at the beginning of the vector. I could even just say end right at the end of the vector. There's nothing in it anyway. Same thing. I'm going to say sc string. I'm going to cast it. We're going to pretend it's a unsigned big integer array. And that plus size of string. We can use size of it because it's an array type. It's just the number of elements in it, the number of characters, is going to be determined by the compiler based on the size of this, the number of characters here, plus 1 for the zero terminator. So it's going to stop when it hits a zero terminator. So now I can do print vector. I don't even want to do that. I actually want to show the string. I'm going to say for const auto, say C for character, come from V, vector, and then print out that character. Okay. Over here, we're going to print a line break, so we're finished printing out the vector. Okay. So far, we haven't even used this. I haven't named it either, you know, cust for customer. But what I want to do here is say cust encrypt. We're going to say the password is going to be, I don't know, maybe some 3. Okay, and then let's do this again after it's been encrypted. Third time after I decrypt it. So cust decrypt AC13. Okay, let's see what that does. Okay, it's 203 affected type specifier before Caesar encryption. Okay. Does it really expect a type specifier? Does it not know what customer is? I think that's the problem here. CUSTOMER, yeah. Oh. Jeez. Right, okay. So 202. Expected. Type specifier. This, what do you mean? Oh, SEAR. Really? Easier. Okay, 217. Letter type. Okay. What am I right now? 217. Okay, good. But I could just do this. Encryption happens from within the class, and the class is defined locally, so I can use a dot operator. Same thing here. Okay. Okay. Interesting. That's because when I printed it out, I didn't actually say what to print, which is supposed to be C here. So C, and there should be one more I'm missing. Right here. Okay. Okay. This is a secret right here. Here's it encrypted. Here's the secret again. Cool. Now what I might have is something like this. Let's say I have int argc v, or you could also do it like this. It's an array of pointers, like it's an array of these. Because I can say if the number of arguments passed us in the command line is less than 2, let's say return 0, usage, let's say whatever the name of the program is, what do I say, customer level, customer tier, let's say, payment tier. Okay, e.g. 0 equals free user, 1 equals paid. Almost wrote paid. Okay. Yeah. Otherwise, what we're going to say is if atoi argv1, so if the second parameter they pass, the first parameter is the name of the program, which is going to be test, right? Test.exe. The second parameter is going to be what they pass, like 0 or 1, right? 0 or 1. I feel like a weird expression. Okay, that. There. So if that equals 0, let's say, or I can even say switch. I'll do that. Yeah. Let's switch it. Okay, and then we'll say case, let's say free tier. Case, paid tier. Something like that. And I'm gonna break out. So here, I'm gonna say, I'll do it up here. Customer, let's say cust. Okay, and here, in this case, I'm gonna say cust equals, oops, a new customer. I'm passing that to it. And then let's say XOR encryption is slightly stronger than the shift encryption. So you gotta pay for that one. So in that case, XOR encryption, the real stuff, gets passed to the paid tier. And then otherwise, default, let's say 1, there's an error here. I mean, I'll say 0 because it's not really an error like as far as couldn't get memory or something. But it is an error as far as like someone entered some bad data. Error. Invalid customer tier specified. Right, okay, now what I want to do actually is show a cool way to make these tiers. So at the top of the program over here, I'm just going to say we have something called an enum, and it's going to be customer tiers, let's say, colon .at. So each of these items in here has this type. So we have free tier and we have paid tier. Now, if you don't specify anything, by default, it's going to start at 0. So this equals 0, this equals 1. Now, if I wanted to, I could say it starts at 1, and this will just become 2. I'm just going to leave it as it is. Yeah, so this will be a 0, this will be a 1. So if they're paying, it'll be paid tiers 1. If they're not paying, it's going to be free tier 0. Okay. Anything else I want to talk about? Let's see it working first. Okay. plane 245. Right, it's a pointer now. So let's use it like this. And at the end, we're actually going to delete the customer. Yeah. Okay, and test. It's going to say, hey, you can't do that. So I'll do... Why is there garbage in there? Oh, right, because I never actually put the first argument in, which is argument 0. That'll be over here. So I was going to get fancy. Arg 0. So remember, when someone's calling your program, the 0th argument is always the name of the program, which is going to be test. That's what I'm compiling it as. And I'm doing that right here, when I'm saying compile the source file, and the output file is going to be test, which becomes test.exe. So there it is. So right here, the full path here, that's our first argument, argument 0. So it's saying, hey, enter a customer tier. 0 for user, 1 for paid, right? So let's try that. I'll do 0. Cool. So that's using our Caesar encryption. And now let's try test 1. That's using XOR encryption. So you can see they're different, but they both still encrypt properly. Okay. So that's kind of an idea of how you might use abstract classes. You basically define some common interface for like some logic you need, and this is the type of functionality I need. I need to be able to encrypt things and decrypt things. I don't really care how, but I want to be able to encrypt something that's a vector of uint8t's, and I want to be able to decrypt something that's a vector of uint8t's. I want to be able to do it by some password in both cases. And I can implement that with AES encryption, or XOR encryption, or Salsa X20, or Cipher, you know, that kind of thing. In this case, I used XOR and Caesar Cipher, which is just like value shifting. And the way you might do that in practice is to have some kind of object that uses any of these methods depending on some situation. Like maybe you want to have a program you make that converts between image formats, right? And you might have some kind of image processing thing that is called like, class PNG handler, right? And this would, abstract from some kind of, or derive from some kind of base, image class, right? Or image, protocol, or whatever you want to call it. Because really what's going to be some kind of like interface, base interface, and then what you would have is like your implementation, right? Some people put IMPL for implementation, right? So you might have interface, you might have like implementation. That's one way to think about it, but you could think of like just it's coming from an image, and this is an implementation of that. It's a PNG handler, and you have another one that's like a BMP handler, which comes from public image. And maybe like what you're doing is you're taking some kind of image, right? Image, right? MG, something like that. And you're going to say, I want to convert between like a PNG and something else. It equals like a new PNG handler, right? Maybe it has a constructor where you can load it from a file. So like you want to say some image.png, right? And maybe what you want to do is you want to say image BMP equals new, I don't know, BMP handler. And this can actually take something like an image, right? So PIMG, right? So now what you've done is you've loaded a PNG file, you stored it in like an image object, and then what you've done is you've made a BMP object, BMP handler, and you've constructed that from some generic image. And the way you can do that is maybe like your image class has something like, a method called like image class, like get pixel data or something. And you can just get the raw pixel data from a PNG or a BMP or a GIF, whatever. And it's able to do that. And then what you could do is, now that you have this, you'll also have a method called like pbmp save, right? You can give it a new file name, so it's going to be some image.bmp. So there's all kinds of cool ways you can use this. It's just that, man, I find this is really, really difficult to think about and to debug. What I would typically do is I would just make it so that each class has some functions that you can do. And what those functions do is based on like some switch statement or something. Like maybe I have some kind of like, I don't know, encryption class like this, and inside of here I'll have like XOR encrypt. And I'll have like Caesar encrypt. And I'll have AES encrypt. Whatever. And then the customer is going to have this encryption class, but based on their tier, the encryption it uses might just pick, to do this one, or pick to do that one, or pick to do that one. That's actually going to execute faster. It's easier to debug, easier to think about. And really all you're doing is just including one class inside of your customer class. It would just be including this encryption class, right? Which I'm kind of doing anyway, but I'm doing it as a pointer to an abstract class, and then I'm picking what kind of class I want when I create the customer. The other thing that's kind of annoying about this is that since I'm kind of picking at runtime which one I want, I have to use a pointer. So the last thing I'm going to do before I stop here is I'm actually going to, well, first of all, I made changes. I'm just going to wipe those out and come back in. I'm going to really stress that you probably should use smart pointers, so standard unique pointer of type customer, which holds a customer star, right? I'm going to call it uptr cust. So I'm wrapping this customer pointer in unique pointer. Okay, and then what I'm going to do with that is I'm going to say, when I'm ready to create a customer, I'll just do standard make unique, type is customer, and there we go. Same thing over here. I'm going to say equals standard make unique, type is customer. Okay, and it's just passing this into the constructor. And then at the end, I actually don't have to delete this anymore because it's unique pointer. Okay, I didn't include the memory header at the top for the unique pointers. So I need, oops. Man, I can't type. Holy crap. Holy moly. Alright, so now it should be able to. Okay, cust was not defined in the scope, right? It's upointer cust, so cust, one. Cust. Okay, cust, come on. Okay, cust. Pointer cust. Cust. Okay. Okay, let's try 0. Okay, let's try 1. Still works. XOR encryption. Here you can see Caesar encryption, decryption. I think that's where I'm going to stop it, honestly. There's a lot of ways you can use this. I think it's a bad way to do it, but with unique pointers, honestly, it's not that more unwieldy than just doing function composition, like I was saying. And usually the speed difference, like how much slower this is, doesn't really matter. If you're doing something in a tight loop where you're creating a bunch of these objects, or you're calling a method from an abstract class over and over again, it might be slow enough where it's going to matter. But anyway, it's important to know how to do this stuff, because a lot of large C++ projects you'll see will have this as the way they function. As usual, if you found this useful, if you have any feedback, please comment and subscribe to help this be a relevant search result in YouTube search results. So thanks for watching. Catch you later.